In this video, we're going to start off with something simple, adding a pause time between our HTTP requests. We are going to make 3 different requests, one to the Get All Video Games API, one to get a specific game, and another call to the Get All Video Games API. We want to add a pause in the script at the end of each API call. Let's get right to it. The first thing that we will do is create a new package in the project where we can store all of our Gatling scripts. Right-click on the source Gatling Scala folder and choose New Package. Give it a name of Simulations. Now right-click on the Simulations package and choose New Scala class. Give it a name of Add Pause Time. Turn this class into a Gatling script by extending off the base simulation class. And add the 2 required imports at the top of the class. Now we are ready to start writing our Gatling script. Let's first check the Gatling cheat sheet for how we might add pause time. We can see that we add a pause by typing .pause and then choosing a time unit. Remember, the script has 3 parts: HTTP configuration, scenario definition, and load scenario. The HTTP configuration has already been done when we set up off the base class, so we don't have to worry about that. Let's go ahead and write the scenario definition. Remember, we want to call the Get All Games endpoint, then the endpoint with a specific game, and finally Get All Games again with a pause in between all the requests. Type val scn equals scenario video game db. This is just declaring the variable that will hold the scenario and giving it a name of video game db. We could give it any name here. Now type exec http get all video games first call. Here we are setting up the first HTTP call. We have given our transaction a name of Get All Video Games First Call. Now type .get video games. This is where we make a GET request to the endpoint at the base URL /video games. Remember, we set up the first part of this call in the base class, so we only need to add in the video games endpoint here. Finally, type .pause 5. This will pause the script for 5 seconds at this point. That's the first call done. Now let's make a call to the second endpoint to get a specific game. Type .exec http get specific game. As before, we are setting up the HTTP call here. Now type .get video games /1. Here we are calling the endpoint at the base URL /video games /1. Now type .pause 120. This will add a random pause of between 1 and 20 seconds. To finish the script, we are again going to call the endpoint that returns all games. Type .exec http get all video games second call. Again, we are setting up the HTTP call here. Now type .get video games. Finally, type .pause 3000 milliseconds. Now, in order for us to specify milliseconds in our tests, we need to import another Scala package. At the top of the class, type import scala.concurrent.duration.durationInt. Now the milliseconds resolves in our script. That's the scenario definition all done. To finish, we just need to add in the load scenario. At this stage, we're going to keep it very simple and just have a single user that executes straight away. Type in setup scn.inject @once_users1. .protocols http conf. What the above code is doing is taking the scenario scn and injecting a single virtual user at once. We are using the protocol http conf, which we set up in the base simulation class. Our script is finished, so let's go ahead and run it. Open the Gatling runner class. Change the name on the sim class line from my first test to the name of our new test. In this case, add pause time. Make sure that the video game DB is running. If it is not, Open up a command prompt, browse to the folder that it is installed, and type Gradle W boot run. Once the application is started, right-click on Main and choose Run Gatling Runner. The test should start a few seconds later. The first call to get all video games happens straight away. There is a 5-second wait till the next call to get a specific game. Then a random 1 to 20 second delay before the last call to get all video games again. And then a final 3000 millisecond wait at the end. Although this was a very simple script, it was great practice at writing a Gatling script from scratch, and it taught us the important concept of adding wait time between HTTP calls. For our next Gatling script, we're going to check that the HTTP response code we get back, such as 200 OK or 500 error, is what we expect. Let's peek at the cheat sheet again to see how we might do it in our Gatling script. If we scroll down to the HTTP checks, we can get a clue for how we might check for a response code of 200. We would need to first call .check and then check the status. In this video, I will show 3 different ways we can check the response code. We can check for a specific code, check that a code is within a range, and check that a code is not something. Let's start writing our script. We're going to write a similar to one to before. It will get all games, then a specific game, then get all games again. Right-click on Simulations and choose New Scala class. Give the class a name of checkResponseCode. As normal, extend the class off of base simulation. And add in the 2 imports. Now let's start writing our scenario definition. Type val scn equals scenario video game db. Again, here we are just setting up the scenario. Now type .exec http get all video games first call. Here we are setting up the first HTTP call. Now type .get video games. Again, we are calling the endpoint at the base URL /video games with this line. Now for the check, type in .check status.is 200. This is telling the Gatling script to check that the status of the HTTP response is 200. Let's now make the second call to get a specific game. Type .exec http get specific game. Here we are naming the call. Type .get video games /1. Now we are making the HTTP call to the base URL /video games /1. Finally, do .check status.in 200 to 210. Here we are checking that the status is anything between 200 and 210. Let's now do the final call to get all video games. Type .exec http get all video games second call. We are naming the transaction here. Now type .get video games. We are making the get call here. Finally type .check status.not 404 status.not 500. Here we are checking that the status is not a 404 and not a 500. Let's finish the script by adding the load scenario. We can copy it from the previous example as it is the same a single user. Now let's run our script. Open Gatling Runner. Change the sim class again to check response code. Make sure the video game DB is running. Now right click on main and choose Run Gatling Runner. The test should execute a lot quicker than the previous one, as there is no pause between the API calls. Everything in the test should pass, so it seems that all the checks were successful. Let's change one of the checks just to be sure that they are working. Change the check in the first API call to check for a 400 response code. Run the test again. This time, we can see an error, status.find.is 400, but actually found 200. So we know that our check is working. Change the assertion back to a 200. In this video, we got more practice of writing a Gatling script from scratch and learnt a few different ways that we can check for response code in our HTTP calls. In the last video, we simply checked the HTTP response code is what we expected. In this video, we will look at ways to check that some text in the HTTP response is correct. First, let's explore our application in Swagger to see what we expect to get back. Make sure that the Video Game DB application is running, and then browse to localhost 8080 Swagger UI index.html. We are going to call the getSpecificVideoGame API endpoint with JSON for the game with ID 1. We can see this is the response body that we get back. We will then write a check in our Gatling script to make sure that the name of the game is Resident Evil 4. To make this check, we will write a simple JSON path query. But first, we need to work out what our JSON path syntax should be. In Google, browse to jasonpath.com. Copy the response body from Swagger to the JSON field. Under JSON path syntax, write $.name. We can see on the right hand side that it has found the name of the game. You can use this site to practice your JSON path syntax. To learn more about JSON path, go here. Back in our project, let's create a new Gatling script. As usual, right click on Simulations, choose New Scala class, give it a name of Check Response Body and Extract. As normal, extend the class off of base simulation and add in the two imports. Now let's start writing our scenario. Type file scn equals scenario, then type getSpecificGame. Then type .get videogames/1. Finally, type .check JSON path $.name is Resident Evil 4. Only the last line contains new code for us here. We are doing a check again, but this time we are looking for a JSON path in our response body. We give the JSON path query and the response text that we expect. Let's finish as normal by adding in the load scenario. Again, we will copy the one from the previous example so that we just have a single user. Now we can run our test. Open up the Gatling runner and change the name of the sim class to Check Response Body and Extract. Make sure the Video Game DB is running. Then right click on Main and choose Run Gatling Runner. The test runs and passes. To make sure the test is working, let's change the JSON path expression to Resident Evil 5. Run the test again. This time, the test fails and gives us an error, as expected. Change the expression back to the correct one now. In this video, we learned how we can use JSON path to check for some expected text in our response body. In the next video, we will look at how we can extract some data from the response body into a variable and then use that variable in a subsequent call in our Gatling script. In this video, we are going to make two HTTP calls. One to get all games and one to get a specific game. In the first call to get all games, we are going to use JSON path again to extract the response ID of a game. In the second call, we will use the extracted value as a parameter in our call. Let's start by looking in Swagger at the calls we will make. First, we will call getAllGames with application JSON. Then we will use a JSON path expression to extract the ID number of the second game in the list, here. Let's practice our JSON path expression first. Copy the response body from Swagger again. Now open up jasonpath.com in Google and paste in the JSON. For the syntax, type $1.id. We can see the game ID of 2 has been extracted. We could also extract the name or the category, but for our test, the ID is fine. Let's go back to our Gatling project. We're going to use the script that we've created before, check response body and extract, and add the two new calls into here. Underneath the last HTTP call, let's write our call to get all games. Type .exec http get all video games. Then type .get video games. Finally, type .check JSON path $(1) .id .save as game ID. What this is going to do is look up this JSON path in the document, in this case the ID of the second game, and save it into a variable called game ID. We can now use this variable in a new HTTP call. Let's write that now. Type .exec http get specific game with parameter. Now type .get video games $game ID. And finally type .check JSON path $.name is Gran Turismo 3. Let's have a closer look at what we typed here. First, we are making a HTTP GET call for a specific game, but instead of typing in the ID, we are using the parameter we saved last time for the game ID. We are then checking that the name of the game we get back in the response body is what we expect. This is similar to what we did in the previous video. Let's run our test to make sure it's working. Go to the Gatling runner class and choose Run. The test runs successfully and the assertion passes. In this video, we showed how we can extract data from the response body of a request, save that data into a parameter, and use that data in a subsequent request. This is commonly referred to as correlation in performance testing. We now know from the previous video how to capture session variables and use them in subsequent requests. As we build out more and more complex scripts, it can be good to have a way to see what session variables we have captured for debugging purposes. In this video, we will explore how to do just that. We will also see how we can capture the entire response body and view that for debugging purposes. We will carry on using the check response body and extract script that we were using in the previous video. We are going to add an additional .exec line at the end of the get all video games API call, the second call, just for debugging purposes. Type in the following .exec session right arrow print line session semicolon session. Now go ahead and run the test again. If we look in the console output, we can see that Gatling has printed out various metadata about the session. We aren't concerned with most of the data, but we can see that our session variable for ID is here with the ID value of 2. Let's now look at how we can capture and display the entire HTTP response code when debugging. We will do this by adding code to the last API call in our script for getting a specific game. Type .check bodystring.saveas response body. Press enter. Now type .exec session right arrow print line session response body dot as square brackets string semicolon session. This is similar to what we did previously, but now instead we are specifically printing out the response body variable that we captured on the previous line. Let's run the test again. If we look at the console output, we can see that the response body of the HTTP call has been displayed for us. So far in our scripts, we have been individually typing out all of our API calls, such as the name of the transaction, which endpoint to call, which checks to run, etc. In later scripts, you will likely find that you want to make the same call more than once. A good way to do this is to abstract the information for each call into its own method or object. We will see how to do that in this video. Let's start by creating a new Gatling script. Right-click on Simulations and select New Scala class. Give it a name of Code Reuse with Objects. As usual, extend the class from base simulation and add in the two imports. To save time and typing, we will use some of the script code that we previously wrote. Open the checkResponseCode.Scala class and copy all the code inside this class and paste into the new class. Do a quick bit of tidying up. Change the check in the third call to be the same as the first, just checking for a 200. And modify the transaction names of the first and third call so that they match. So now our script has 3 calls in total, and the first and third ones are the same, so there are only 2 different calls. Let's now write our methods to represent both of these calls, starting with the one to get all games. Type def get all video games. Now copy all the code for the first API call and paste it here. Now type def get specific video game. Now copy all the code from the second API call. With the 2 calls defined in methods, we can rewrite the scenario to use these methods instead. Type val scn equals scenario video game db. Press enter and type .exec get all video games. Let's add a pause. Type .pause 5. Press enter and type .exec get specific video game. Add another pause. Type .pause 5. Finally, type .exec get all video games. To finish, either comment out or delete the original scenario definition. Let's go ahead and run the test to see if it works. Open Gatling Runner. Change the name of the sim class to Code Reuse with Objects. And run the test. Our script runs nicely, and with the pause of 5 seconds between the requests. Writing our Gatling script in this way makes the scenario definition a bit easier to read, abstracts away some of the logic in our script, and gives us some code reuse. Now that we know how to put our HTTP calls into methods, we can also make those method calls loop. Let's look at how we can make a method called loop a set number of times. First, let's have a peek at the Gatling cheat sheet again to look for a clue as to how we can do this. We can see under loops that there is a repeat option. This is what we want. Back in our project, let's modify the Code Reuse with Objects script. Let's make get all video games loop 3 times when it gets called. Type in repeat 3. Tidy up the brackets so that the code for the API call sits inside the repeat brackets. Let's also change get specific video game to loop 5 times. Type in repeat 5. Tidy up the code again. Go ahead and run the test. We expect get all video games to repeat 3 times, then get specific game to repeat 5 times, then get all video games to repeat 3 times again. We can see in the report that we called get all video games 6 times and get specific game 5 times, just as we expected.